Okay, so today we're doing how we're going to graph the cosine function. So the very first thing I want to look at is this parent function y equals cosine x. Okay, so I've got some x values that these come from going around the unit circle. So if I try, if I plug 0 pi into this equation, what's the cosine of 0 pi? Well, I'd look at the unit circle at 0 pi, the cosine is the x value, so the cosine of 0 pi is 1. Right? And so we can complete that as we go around at pi over 2, pi, 3 pi over 2, and 2 pi. The cosine of pi over 2 is the x value at pi over 2, which is 0. At pi, it would be negative 1, 0, and 1. So again, all these values come from taking these and plugging them in for this x, solving for a y. Okay, now from this table of values, I see that I have a maximum of 1 and a minimum of negative 1. And I start at 0 pi, go to pi over 2, make that a little cleaner, pi, 3 pi over 2, and 2 pi. Now if I'm going to graph each of these points, at 0 pi I'm up here at 1, pi over 2 we're at 0, pi we're at negative 1, 0, and 1. And whenever I connect these with this curve, where I'm kind of like doing this bowl shape, whoop, missed. That's the parent cosine function. So just to note some differences from the sine function, sine started here at the origin, whereas the cosine started up here at 1, right? But as long as we have two pieces in the upper region and then these two are connecting in the lower, that completes one whole period. And for the parent function, the period is 2 pi. Okay, but we're going to concentrate on y equals a cosine bx. Okay, where the amplitude is the absolute value of a. So asking for a versus asking for the amplitude is always positive. Now, if that a is negative, if you have a negative a, you're going to start at your minimum. And the minimum is negative a. If you have a positive a, you'll start at the max, which is just a. The period we find the same way as we find the period for a sine. The period is 2 pi over b. Okay, and the increment is found the same way as well. It's just the period divided by 4. And just remember that this is the same thing as the period times 1/4. So if you're ever dividing by a fraction, or if you have a fraction being divided by 4, it might be easier just to multiply by 1/4. Okay, we're going to find the amplitude, the min, max, starting point, increment, and graph. Whenever I'm talking about the min and max and starting point, I just want to make sure that we're listing those before we get into the translations, because then we'll start moving the x value of the starting point. Alright, so we're looking at y equals negative 5 cosine of 3x. So the a is negative 5 and the b is 3. Right? So from the a being negative 5, what's my amplitude? Okay, the amplitude's 5. So I'll go ahead and start graphing this. So 5, negative 5. So what's the minimum? Yeah, the minimum will be the point 0, negative 5. Even though there's a bunch of the negative 5s, we're going to list our minimum as that first minimum, that 0, negative 5. And we'll have a max. Our max will be at 5, but we'll just list this as 0, 5. where are we starting? At the minimum, so 0, -5. Now the period is 2 pi over b. So 2 pi over b. And my b is 3, so this would just be 2 pi over 3. So I know to complete the period, I have 1, 2, 3, 4 marks. The last mark is 2 pi over 3. Okay. Now the increment, you can either divide that by 4 or multiply it by a fourth. So in this case, multiplying it by a fourth will actually be easier for us because we had a fraction being divided by a whole number. So the 2 and the 4 can cancel down. My increment is pi over 6. Okay. So each step that I take from the beginning, from this 0 pi, will be pi over 6. So each step is pi over 6. So 1 pi over 6. The next step would be 2 pi over 6, 3 pi over 6, 4 pi over 6. Because each time we're taking a step of 1 pi over 6. But whenever we graph this, we reduce them. 2 pi over 6 is pi over 3. 3 pi over 6 is pi over 2. And this final one, 4 pi over 6, it reduces to 2 pi over 3. So I know I did it right. So let's get rid of this. Since it's -5, we know that we're going to start down here at the negative. And then just complete your sine wave. I mean your cosine wave. What am I talking about? So it's the U shape. And that's the cosine for one period of -5 cosine 3x.
That's really easy.
All right, this time we're going to graph over 2 periods. Okay? So we have y equals 3 cosine of x over 5. So the amplitude is 3. The minimum value will be -3. And the maximum value will be 3. I know last time we listed those as points. This time we're not going to do that. Like, just know that a min or a max is a y value. Okay? But where's our starting point? At 0, 3, or -3?
3.
Why is it 3? Because this is a positive 3 right here. Okay. The period. So that's 2 pi over 1/5. So that's the same thing as 2 pi times 5 over 1. So the period is 10 pi. Now, if the period is 10 pi and we're graphing over 2 periods, how far are we going to go? 20 pi. That's right. Okay, but let's figure out our increment. It'd be 10 pi over 4. So every step is going to be 5 pi over 2. Okay, so we're going to graph this over 2 periods. And every step is 5 pi over 2. So my first step is 5 pi over 2. The next step I'm going to go another 5 pi over 2. So that puts me at 10 pi over 2. 10 pi over 2 is just 5 pi. Okay, after 10 pi over 2 I go another 5 to 15 pi over 2. Another 5 puts me at 20 pi over 2, which is
10 pi.
And look, that's my first period right there. Okay, now I'm at 25 pi over 2. Another 5 would be 30 pi over 2, which is 15 pi. 35 pi over 2. And then 40 pi over 2 is 20 pi. So again, these steps that don't have divided by 2, these are coming from just going 5 more each time. So 10 pi over 2, this is 20 pi over 2, 30 pi over 2, and 40 pi over 2. Okay, so now that we know where all of these points came from, let's graph. Since it's a positive 3, I'm going to start at my max. So 3, negative 3. Start here at my max, and then I'm just going to go through all the same steps. Connect all the points. And I've graphed this over 2 periods. You can see right here where it starts to repeat itself. And that's graphing cosine.